Los Alamos National Laboratory, the summer of 1950. The cafeteria at Fuller Lodge. Enrico Fermi, Edward Teller, Emil Konopinski, and Herbert York walk into lunch. They have been talking on the way over about a New Yorker cartoon, flying saucers carrying off New York City rubbish bins. The conversation turns to faster-than-light travel and the probability of extraterrestrial civilizations. They sit down. Fermi is quiet for a long time, then he says, "But where is everybody? Where is everybody?" The question Fermi asked at lunch on that afternoon at Fuller Lodge is the central question of the search for extraterrestrial intelligence. The Milky Way galaxy is 100,000 light-years across. It is 12 billion years old. It contains between 100 billion and 400 billion stars. If even 1 in 100 has planets, and even 1 in 100 of those is in the habitable zone, the number of possible homes for life is in the hundreds of millions. And yet Fermi observed, the sky is silent. Enrico Fermi was awarded the Nobel Prize in Physics in 1938. He had built the first artificial nuclear reactor, Chicago Pile-1, in a squash court beneath Stagg Field at the University of Chicago on the 2nd of December 1942. He had led the K-25 gaseous diffusion plant work at Oak Ridge during the Manhattan Project. By 1950, he was a senior staff member at Los Alamos. The lunchroom question that day was not a casual remark. Fermi had run the numbers in his head. Source: the original transcribed recollection of Herbert York, Argonne National Laboratory archives. The Fermi paradox was named 25 years after Fermi asked the question. Michael H. Hart, an astrophysicist at the National Center for Atmospheric Research, published a paper in the Quarterly Journal of the Royal Astronomical Society in Volume 16, 1975. An explanation for the absence of extraterrestrials on Earth. Hart laid out the colonization argument. Any civilization capable of 1% of the speed of light could colonize the galaxy within 10 million years, 1,000th of the galaxy's age. The absence of any such civilization here is therefore evidence of their absence everywhere. 12 years before Hart published, on the 1st of April 1960, a young radio astronomer named Frank Drake had pointed the Tatel 26-meter dish at the National Radio Astronomy Observatory at Green Bank, West Virginia, toward the stars Tau Ceti and Epsilon Eridani. Drake was looking for intelligent radio signals at the 21-centimeter hydrogen line. The project ran for 4 months. It heard nothing of obvious extraterrestrial origin. Project Ozma was the first sustained search for extraterrestrial intelligence. The next year, on the 1st of November 1961, Drake convened a small conference at Green Bank. 11 attendees. Among them Drake, Carl Sagan, Otto Struve, Philip Morrison, Melvin Calvin, Frank D. Drake and Bernard M. Oliver. The agenda: to structure the question. Drake wrote a single equation on the chalkboard. The number of communicating civilizations in the Milky Way is equal to the rate of star formation, multiplied by the fraction of stars with planets, the number of habitable planets per such star, the fraction that develop life, the fraction that develop intelligence, the fraction that communicate, multiplied by the length of time they communicate. Source: Drake's chalkboard, photographed at the close of the meeting. R star: the rate at which new stars form in the Milky Way. The current best estimate from Robitaille and Whitney at the Spitzer Space Telescope Glimpse program is 1.5 solar masses per year, equivalent to roughly 1 new star per year of solar type. The Milky Way has been forming stars at this rate for 10 billion years. The first term of the equation gives us roughly 10 billion stars formed across galactic history. P the fraction of stars with planets. In 1961, Drake guessed half. The Kepler Space Telescope mission, launched on the 7th of March 2009 and operated until October 2018, observed 200,000 stars continuously for 9 years. The result, published by Burke and team in 2015, Almost every main sequence star has at least one planet. P is now estimated at very close to 1, the number of planets in each system in the habitable zone. The Kepler data combined with the transiting exoplanet survey satellite results give a current best estimate from Bryson and team in 2021. Between 0.37 and 0.6 habitable zone planets per Sun-like star. Drake's original guess was 2. The data has not been kind to the higher estimates, but it remains positive. FC the fraction that develop life, the fraction that develop intelligence, the fraction that develop technology and transmit. These three terms are unknown. Earth is the single data point. Life arose here within 400 million years of the planet's formation, which suggests FL is not particularly small. The path from prokaryotes to humans took 3.5 billion years and required the Cambrian explosion of complex animals. The path from humans to radio transmitters took 50,000 years. Each fraction could be near 1. Each could be vanishingly small. We do not know. How long does a civilization broadcast? The argument is unsettled. Earth has had radio for 120 years. The strongest dedicated broadcasts, the Arecibo message of the 16th of November 1974, were brief. The Voyager golden record will outlast the Sun. The hydrogen line search assumes L is between 1,000 and 100,000 years. The most pessimistic estimates assume L is 50 years, and we are already past it. Carl Sagan, professor of astronomy and space sciences at Cornell University, was at the Green Bank meeting in 1961. He was an editor of the Voyager Golden Record. He had reviewed every NASA mission's biological contamination protocols. In 1980, he published Cosmos, the book and the 13-episode television series, which brought the Drake equation, the Fermi paradox, and the framing of human cosmic perspective to 1 billion viewers worldwide. Sagan's framing of the question, that we may be the universe's way of knowing itself, has been imitated and rejected in equal measure ever since. The 15th of August 1977. The Big Ear radio telescope at the Ohio State University Perkins Observatory, near Delaware, Ohio, recorded a narrowband 72-second radio signal at 1,420.4 MHz, the 21-centimeter hydrogen line. The signal intensity was 30 times above background. Jerry R. Amon, an astronomer reviewing the printout the next morning, circled the relevant characters and wrote the word "wow" on the margin in red pen. Amon, the astronomer behind the discovery, sought a repeat of the signal at the same coordinates over the next several years. The Allen Telescope Array at the SETI Institute, the Very Large Array, the Robert C. Byrd Green Bank Telescope. The WOW signal was never detected again. Its source coordinates lie within the constellation Sagittarius. Its origin remains unknown. Robin Hanson, then an economist at the Hoover Institution at Stanford, in 1996 published an essay, The Great Filter, Are We Almost Past It? Hanson's argument, either the steps from interstellar matter to a long-lived communicating civilization, are improbable as a class, in which case some single step is so hard that it has happened only once or twice in galactic history, or it is the late steps, survival of one's own technology, the avoidance of self-destruction that filter civilizations out. The earlier the great filter lies, the better Earth's odds. The later it lies, the worse. Hanson's argument has a sharp consequence. If we should discover fossilized microbial life on Mars, our position becomes worse. If life is common, the filter must lie further along the chain, and we have not yet passed it. The argument was sharpened by Nick Bostrom of the Future of Humanity Institute at Oxford in 2008. Bostrom, let us pray that future Mars missions discover no signs of life. We do not want to learn that the universe is full of failed attempts. Brandon Carter of the Cambridge Institute of Astronomy in his 1983 paper, the anthropic principle and its implications for biological evolution, argued that the long time required for human-level intelligence to evolve on Earth, 3.5 billion years from the first prokaryotes, is itself evidence that the relevant biological steps are extraordinarily improbable. Carter's reasoning was anthropic. We can only observe a planet on which intelligence arose. The timescale tells us how unlikely the chain is. On the 6th of June 2018, Anders Sandberg and Eric Drexler at Oxford Future of Humanity Institute, with Robin Hansen and Stuart Armstrong, published Dissolving the Fermi Paradox. The paper argued that the Drake equation, as commonly applied, combines best guesses for each term, but the actual uncertainty range across each term is many orders of magnitude wide. When the uncertainty is propagated probabilistically rather than as a single-point estimate, the resulting distribution for n, the number of communicating civilizations in the Milky Way, includes substantial probability mass at n less than 1. We may simply be alone. The paradox dissolves. Sandberg and team's result. The median outcome, taking the full uncertainty across every term of the Drake equation, is that the Milky Way contains 0.7 communicating civilizations. The probability that we are alone in our galaxy is somewhere between 1 in 3 and 2 in 3. The probability that we are alone in the observable universe, every galaxy, every star, is between 1 in 20 and 1 in 5. The numbers are not zero, they are not large. On the 14th of February 1990, at 32 minutes past 4 Universal Coordinated Time, the Voyager 1 spacecraft turned its narrow-angle camera back toward Earth. The spacecraft was 6 billion kilometers away, 3.7 billion miles. The Sun was 100 times more distant than from any human observation point in history. Voyager 1 imaged the inner solar system in a 60-frame mosaic. Earth occupies 1 pixel of the pale blue dot frame. The image was downloaded over the next several hours. Carl Sagan had requested the maneuver 7 years earlier. Sagan, in his book Pale Blue Dot, published in 1994, wrote, "Every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light." The framing has been quoted and requoted at every Voyager anniversary. It is the founding text of the All Without Mysticism register. Each Voyager spacecraft carries a golden phonograph record, 12-inch gold-plated copper disc. Selected by Sagan, Frank Drake, Anne Druyan, Timothy Ferris, Linda Saltzman Sagan, and John Lommberg between June and August 1977. 115 images of Earth. Greetings in 55 languages. 27 pieces of music, including J.S. Bach's Brandenburg Concerto No. 2 third movement, Chuck Berry's Johnny B. Good, a Bulgarian Bushman song, and Beethoven's String Quartet Opus 130. The record is etched with instructions for use. It is humanity's reply to the Fermi paradox. Voyager 1 crossed the heliopause on the 25th of August 2012. The spacecraft is currently moving away from the Sun at 17 kilometers per second, 10.6 miles per second. It will reach the inner Oort cloud in approximately 300 years. It will pass within 1.6 light-years of the star Gliese 445, sometimes called AC plus 793888, in approximately 40,000 years. The record will be readable. The Voyager team estimate that the spacecraft's surface inscriptions will last over 1 billion years. The 14th of September 2015, at 9:45 Universal Time. The Laser Interferometer Gravitational Wave Observatory at Livingston, Louisiana detected a signal at 150 Hz that swept upward through 250 Hz over 0.2 of a second. The signal was independently confirmed at Hanford, Washington, 0.7 of a second later. It was the gravitational wave from the merger of two black holes, 29 and 36 solar masses, at a distance of 1.3 billion light-years, GW 150914, the first direct detection of gravitational waves. The era of multi-messenger astronomy had begun. The James Webb Space Telescope was launched on the 25th of December 2021 from Kourou, French Guiana. Its first deep-field image was released by NASA on the 11th of July 2022. SMACS 0723, the deepest infrared view of the universe ever taken. The image contains galaxies as they appeared 13.1 billion years ago, 400 million years after the Big Bang. None of those galaxies have yet revealed evidence of a communicating civilization. The hydrogen line search continues at the SETI Institute and at the Breakthrough Listen program. After 74 years, the current best scientific answer to Fermi's question is, we do not know. The Sandberg analysis suggests we may be alone. The wow signal suggests we may not be. The Drake equation, written on a chalkboard at Green Bank in 1961, formalized what we do not know rather than answering it. The great filter, whether past or future, remains undetermined. The James Webb Space Telescope sees galaxies 13 billion years old. None of them is broadcasting to us. The silence is the data. Los Alamos, the summer of 1950. Enrico Fermi at Fuller Lodge. Fermi died of stomach cancer at his home in Chicago on the 28th of November 1954. He did not live to see Project Ozma, the Drake equation, Cosmos, the wow signal, the great filter, the Voyager golden record, the pale blue dot, gravitational waves, the James Webb Space Telescope, or the Sandberg analysis. The question he asked at lunch on a summer afternoon, "Where is everybody?" has been studied for 74 years and not answered. The investigation continues at every major radio observatory on Earth. Ronald Bracewell of Stanford Electronics Laboratories in 1960 proposed that any sufficiently advanced civilization would not broadcast across light years. They would send physical probes to stellar systems of interest. A Bracewell probe stationed somewhere in the solar system, perhaps at a Lagrange point or on a small asteroid, would record our transmissions and wait. We have not searched the Lagrange points carefully. The Breakthrough Listen program is funding such a survey. The result is not yet in. 3 classes of answer remain on the table. 1. We are alone. The Sandberg analysis says this is plausible. 2. They are out there but separated from us by such enormous distances and timescales that our windows of mutual broadcast do not overlap. The Milky Way is 100,000 light-years across. Any signal we send now reaches its target in geological time. 3. They are out there and silent by deliberate policy. The dark forest hypothesis, formalized by the Chinese author Liu Cixin in 2008, argues that broadcasting is dangerous. Predator civilizations may listen. The galaxy may be a forest of hunters in the dark. Fermi at Fuller Lodge in 1950 was a senior physicist at the height of his career. He had built reactors. He had run the numbers in his head over lunch. His 4-word question, "Where is everybody?" has occupied 74 years of the most expensive radio telescopes in human history. The Allen Telescope Array continues to scan. Breakthrough Listen is processing a petabyte of data each week. The James Webb Space Telescope has imaged galaxies from when the universe was 3% of its current age. The question is still open. The investigation continues. The silence is the data.